For our next example, it wants us to find the vertex, focus, and directrix, because notice now we see pluses and minuses there within the quantities. So we've got an h and a k. Now, with the x quantity being the one that's squared, that's the one we're familiar with. That's the one opening up and down. So this is a vertical parabola. We can look at the h and the k here because we know h corresponds to x, k corresponds to y. So we know our vertex is going to be at the point, well, if this is x minus 3, then h is 3. Y plus 1 would mean k would be a negative 1. So that's going to be our vertex of 3, negative 1. And we can use this 8, again set equal to 4p, to find out that p is a positive 2. So let's start with the vertex at 3, negative 1. Okay. Then we'll use p for the distance, but it's a positive p, and it's a vertical parabola. So it's opening up and down, and p is the distance from the vertex up and down. So opening up means this 2 away should be my focus, and down 2 away should be the directrix, so that this parabola can open upward around that focus. And so we have our vertex that we found. We can say that our focus will be at that point, 3, 1, and the directrix will be down here, a horizontal line at y equals negative 3. So lastly, we get to an equation similar to the ones we saw for parabolas and ellipses, or hyperbolas and ellipses, where it's not in that graphing form yet. Now the difference here is you do not need to complete the square twice. You've only have the one squared quantity for any graph of a parabola. So you just identify which variable is being squared, and that's going to be the one that we're going to need to complete the square on. What that means is we're going to move not just the constant, but the x term as well to the other side. So y squared plus 2y, leave some space for completing the square, equals negative 12x minus 3. Plus 23. Moving both those terms to the other side, subtracting 12x, adding 23. So with this form, let's work on the complete the square here. This 2 for our b term, so we divide that by 1 and square it. 2 divided by 1 is 1, squared is still 1. Since we just added 1 there, we're going to add 1 to the other side. We want to keep them balanced. Here is where we can factor and get that perfect square of y plus 1 squared. Over here, first thing I would do is combine those two constants, 23 and 1, to get 24. Now, the next thing we need here, we need this to look like that general form, which in this case will be y minus k squared equals 4p times x minus h. To get this into that form, notice we really just need to factor out this GCF, whatever it is. And so with y plus 1 squared, factoring out the negative 12, leaving me with x minus 2, gives me the form I'm going to need, so that now we can identify things like our hk center. So again, k is with y, h is with x. So h for x minus 2, h is 2. K for y plus 1 is negative 1. So there is our vertex of our parabola. Then we take the negative 12, and that needs to be equal to 4p. Divide both sides by 4, and p is negative 3. So I've got my vertex, I've got my value of p. We haven't written it down yet, but to identify that since it's the y squared quantity, that's going to be our horizontal parabola. So when we get this vertex down here of 2, negative 1, if it's a horizontal parabola, it's opening either right or left. And since p is negative, it's going to open to the left. And if it opens to the left and p is negative 3, I go 1, 2, 3, and that's where my vertex is, or my focus is. 1, 2, 3 to the right will be where my directrix is, because I need this to wrap around my focus. So from there, we can just identify, we've got the vertex already. We know the focus based on that graph is at the point -1, -1, which is 3 to the left of the center of the vertex. And then the directrix is that vertical line located at 5. So x equals 5.